those electrons in, and therefore ends up with a slightly negative charge. For oxygen, because it's more electronegativity, then would be hydrogen, they end up with a slightly positive charge. Okay, so with that in mind, now we're going to introduce another type of bond, and these bonds are called hydrogen bonds. So hydrogen bonds, we learned and we saw the example of water, right? So we saw water. Okay, so if I have a water molecule, I have an oxygen molecule bonded to a hydrogen, bonded to a hydrogen. And we concluded that this bond between oxygen and hydrogen is a single bond because there's only 2 electrons being shared between the oxygen and the hydrogen. And we also made conclusions, and we said the hydrogen ends up with a slightly positive charge. And we also said that oxygen ends up with a negative charge. And the reason is because the water is a polar molecule. They share electrons, but the sharing of these electrons is not equal. Okay, so where is these hydrogen bonds, where do they come in, right? When do these new bonds come in? Well, now if I'm looking at within the water molecule, so I could say that there is covalent bonds between within the water molecule. And yes, that's true. This is a covalent bond. Okay, so however, if I'm now looking at different water molecules, so let's say I have a water molecule over here. Let's say I have another water molecule right here. Another one over here. So now I'm looking at multiple water molecules, right? And I'm going to go ahead and put their charges slightly positive, positive, negative, positive, positive, negative, negative, slightly positive, slightly positive. Okay, so now there's charges. Oxygen is slightly negative, hydrogen slightly positive. So this is now a new bond forms. So now there's a slightly negative charge here between an oxygen of one water molecule and a slight positive charge on the hydrogen of another water molecule. So I'm going to call this water molecule 1, 2, 3, and 4, right? So now what happens is, because there's a negative here and a positive here, now there's a new bond that is formed between these opposite charges, and that bond is called a hydrogen bond. And that could happen with, depending on the arrangement of the molecules. So here's another one that happens between this hydrogen and this oxygen. There's another one. So everywhere where hydrogen and oxygen come into together, then you make those bonds, right? So if there's another water molecule on this end, there would be another bond, and so on. So these are, again, so hydrogen bonds, a molecule of water, molecule. I think there's a wording issue there, but a molecule of water, maybe not, again, consists of 2 atoms joined to one oxygen atom. So within the water molecule, you make covalent bonds, but between water molecules, you make hydrogen bonds. Okay, so let's write that down. So you could say, so within a water molecule, you have covalent bonds. Okay, so that is within, right? So by within, I mean that. These bonds right here. That's a covalent bond, that's a covalent bond. Okay, but between water molecules, you have hydrogen bonds. And as you could tell, like if you look at within one water molecule, there's a covalent bonds, but if you have two water molecules between them, you're gonna make these hydrogen bonds. And as you could tell in this picture, so you have the red, they represent the oxygen, and the white, they represent the hydrogen.
Got it, okay.
Yeah, so then you have water molecules, which is one oxygen, two hydrogen. And as you could tell, like the hydrogen, they have a slight positive charge. The oxygen have a slight negative charge. So now this is the interaction between water molecules. So because of one having a positive and the other one a negative, now there's a new bond form, which is called the hydrogen bond. These bonds are pretty weak. That means that you could easily break them. And this brings a whole new concept of like water, like why we have water in different states. You have water as a liquid, you have water as a solid, you have water as a gas, which are the three different states of matter, right? And how these bonds is gonna play a huge role on how the bonds are formed. So what if you think about like what makes a liquid versus a solid with respect to water? Well, it has to do with their hydrogen bonds. So if you have water in a liquid form, the hydrogen bonds are pretty like chaotic, and they break and they break and reform and so on. They're very like unstable, as opposed to when you have water in a solid state, the hydrogen bonds are very stable and very far apart from each other, right? So later on we'll talk about like the properties of water, but here it's like understand like when we're looking at water, if you look at a single water molecule, what connects the hydrogen to the oxygen within that specific water molecule, we're looking at covalent bonds. And these covalent bonds, this formation of the covalent bond is because water happened to be a polar molecule. And then you back and you can determine what is a polar molecule. Well, polar molecule means that there is a sharing of electrons, but this sharing is not equal. And because this sharing is not equal, you end up with hydrogen having a positive charge and oxygen having a negative charge. Now, if you have these molecules that have these slight charges interacting with other water molecules that have also these slight charges, now because of those charges, you end up making a new bond. These are called the hydrogen bonds. So let's look at closer. Let's look at a video where you could see the formation of these bonds.
Water has many extraordinary properties. Small animals can walk on water. More importantly, in comparison with other liquids, it takes a lot of heat energy to change the temperature of water or to make it vaporize, to change it from a liquid to a gas. This is because individual water molecules are polar and they stick together by means of hydrogen bonds. The atoms that make up a water molecule are in a constant tug of war over their shared electrons. Oxygen is more electronegative than hydrogen, So oxygen exerts a far stronger pull on the shared electrons than hydrogen does. Thus, the electrons spend more of their time closer to the oxygen atom. Because of this unequal sharing of electrons, the oxygen atom in a water molecule actually has two regions of partial negative charge, and each hydrogen atom has a slight positive charge, even though the water molecule as a whole is neutral. Because of the unequal sharing of electrons and the resulting positive and negative poles, the bonds between oxygen and hydrogen are called polar covalent bonds, and a water molecule is said to be polar. The polarity of water molecules causes them to be attracted to each other. There is an attraction between a positively charged hydrogen atom of one water molecule and a negatively charged oxygen atom of another water molecule. Since the positively charged atom in this type of attraction is always a hydrogen atom, this type of bond between molecules is called a hydrogen bond. Each water molecule can hydrogen bond with up to 4 other water molecules. A hydrogen bond is weak and lasts only a tiny fraction of a second, but it takes a lot of energy to overcome the combined attraction of many hydrogen bonds in water. This explains water's great capacity to store heat, its high boiling point, surface tension, and several other properties of water.
Okay, so now it brings us almost towards the end of chapter 2. Then now that we know the properties of water, we also know that water forms covalent bond within the water molecules, and also it forms hydrogen bond between water molecules. That kind of gives us perspective of life and how we're tied to water, right? So if you think of our cells, like a huge percentage of our cells are composed of water, right? So when we transition life, like if we think something simple like a plants, like the origins of life, it's transitioning from like an aquatic form to terrestrial form. So the abundance of water is one of the major reasons why Earth is habitable, right? So if you ever hear like, oh, there's a new planet, one of the first things that you want to know is there life in the planet, and maybe if there's life, one of that they go even more basic, is there water in the planet? Is there evidence or traces of water? Okay, so again, water is very important because of its polarity, and also is very important because it is found in different states of matter. You find it in a liquid, solid, gas. So now there's another concept. So water molecules have a tendency to stick together, and the reason why they stick together is because of hydrogen bonding. So now you're going to see the tendency of molecules of the same kind to stick together. So think of like water molecules sticking to one another. So because they have this tendency to stick together, and they do because of something called cohesion. So now cohesion is the idea that is one water molecule connecting with another water molecule, connecting with another water molecule. So for example, you could see that concept on that specific spider kind of like sitting on top of water, and you see like the indentations, how it's kind of like not sinking.
Damn.